Welcome to the Explainer. So if you're just cracking open Chapter 1 of your economic studies, you probably already know the real world is, well, it's incredibly complex. It's filled with moving parts, unpredictable human behavior, and literal mountains of information. But don't worry, today we're building your visual survival kit to help you tame all that data.
Because as a budding economist, you are inevitably going to hit walls of confusing statistics. Whether it's data from the government, big banks, or international organizations, looking at raw numbers can feel entirely overwhelming. So, the secret to surviving? Learning to visualize it. Let's look at exactly how we can take intimidating data and turn it into clear, compelling pictures. Here's our masterclass lesson plan for today. We'll cover why visualize economics, diagrams versus graphs, the essential diagrams you need to know, the golden rules of drawing them, and finally, using technology in economics.
All right, let's jump right into part 1. Why visualize economics? Turning confusion into clarity.
You know, when you're staring at rows and columns of raw numbers, it's so easy to get lost. Or, let's be honest, just get a massive headache. But a single visual? That can cure math anxiety instantly. Instead of trying to memorize endless grids of data, a picture lets you spot trends across years and regions in a fraction of a second. Plus, those really tricky principles, like the expansion and contraction of demand or unpredictable fluctuations in agriculture, they become so much easier to grasp when you just map them out visually.
Moving on to part 2, diagrams versus graphs, the billboard versus the blueprint.
Now, what's really interesting here is that people use these two terms interchangeably all the time in everyday conversation. But in statistics, they are completely different things. Think of diagrams as a public billboard designed for really easy reading, while graphs are the complex blueprints that researchers use. A diagram is drawn for self-explanatory data. You don't need a PhD in stats to understand one, which is exactly why advertisers love them. A graph, on the other hand, is a totally different beast. It requires statistical tools and is used heavily by researchers and educators to plot continuous frequency distributions across an X and Y axis.
And this table brilliantly illustrates the difference in the underlying data we're talking about. Distinct, discrete values get a diagram. Think of a specific price point of 1, 2, or 5 repeats, and the exact demand at that exact price. But if you have continuous data that tracks ranges, like counting how many people fall into income brackets from 10K to 20K and 20K to 30K, you need the blueprint. You need a graph. Okay, part 3, the essential diagrams. These are the core visuals for every student.
Let's open up that toolkit. A simple bar diagram compares one variable over a base. Take a look at these bi-monthly sales of chocolate boxes. The base time period sits right there on the x-axis, while the sales volume goes up the y-axis. We draw a separate bar for each time period, and just by comparing the heights, boom, we instantly understand when sales peaked. It gives a really powerful visual effect of the difference in values.
But what happens if the data gets a little more complex? Say our chocolate shop started tracking small, medium, and large boxes sold during those exact same months. Well, we'd simply upgrade to a clustered bar diagram. We'd put 3 differently colored bars together in a little cluster for each time period. Or, alternatively, if we wanted to show the total sales per month, but visually split that total into rural versus urban sales, we'd use a divided bar diagram. Every single bar represents the whole total, but it's divided in color to show those subcategories. Pretty neat, right?
Now, when you need to show how an entire universal set is divided up, like, say, a student's total pocket money, you use a pie diagram that's proportional to 360 degrees. Because an entire circle is 360 degrees, the whole data set represents those 360 degrees. So, to find the slice for food, which makes up 30% of the student's spending, you just calculate 30 multiplied by 360 divided by 100, which gives you 108 degrees. You simply map out these proportionate degrees, and you can show exactly where all that money goes. Part 4. Golden Rules of Drawing. Consider this the student's checklist for perfect charts.
Before you submit any assignment, you absolutely need to run through this golden checklist every single time to ensure your picture is authentic and, actually makes sense. First up, choose the right diagram. Sometimes a bar is better, sometimes a pie is the way to go. Keep it clear by using different colors or shades. Make sure your scales are actually appropriate for the data you're showing. Both the X and Y axis must be clearly labeled. And honestly, perhaps most importantly for your grades and your credibility, always include the data table you used, state your source, and mention any statistical methods you applied.
Specifically for bar diagrams, remember this golden rule.
The width means absolutely nothing, but the length means everything. All your bars should be of equal width, simply because the width doesn't actually represent any data. The length, however, must be strictly proportional to the value it represents. You also need to maintain an equal distance between all the bars to keep things neat. And finally, all bars must rest on the exact same baseline, typically the x-axis, arranged left to right.
Finally, Part 5. Technology in Economics. Upgrading your analytical toolkit.
You know, the real world changes rapidly, and economics evolves every single day right alongside it as human behavior changes. Just like we rely on our smartphones to navigate traffic or pay bills, modern economists rely on tech as the vital bridge to cope with this constant flood of new data. It has completely revolutionized how we handle economic education and research. Honestly, think of these modern tech tools as your economic superpowers. Excel worksheets can process thousands of economic observations in a literal flash. PowerPoint can boil a massive, complicated national budget down to just 3 clear slides. And for the really heavy lifting, statistical software like SPSS or Gretel can chew through massive datasets from places like the WHO or the Reserve Bank of India in minutes. Plus, the internet gives you direct, instant access to giant macroeconomic datasets.
But, and this is a big but, a computer will happily generate the completely wrong graph if you enter the wrong formula. Technology is merely an aid. It absolutely does not replace the hard process of studying or your own critical reasoning. There is a lot of substandard, unauthentic material floating around online. You still need to cultivate the wisdom to identify authentic websites and correctly input your data commands. Otherwise, you'll just be analyzing bad data really fast.
So, the next time you see a chart pop up in your news feed or in a textbook, don't just passively scroll past it. Ask yourself, is this a billboard diagram meant to persuade the general public or a blueprint graph meant for serious researchers? What story is it really trying to tell? Or maybe, what is it trying to hide? You now have the visual survival kit to not just study economics, but to really see the matrix behind the data. Thanks for joining me on this explainer, and remember to stay curious.